Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. My name is Zafan Walbajwa, and today I will talk about the oils and fats. Oils and fats. Introduction to oils and fats and refining of oils and fats. So let's start the introduction. Lipids. Lipids form the third type of natural substance apart from carbohydrates and proteins. Among the four types of lipid, we will discuss only fats and oils. The four types are lipid, oils, fats, waxes, and etc. First of all, we talk about the oils and fats. Oils and fats. These are the esters of glycerol with higher fatty acids and are also called glycerides or are also triglycerides. Now coming towards this chemistry of fats and oils. Fats and oils are composed of glycerol. Glycerol is alcohol that is trihydroxy 1,2,3 trihydroxy alcohol and fatty acids with even number of carbon like to range the range of carbon number of fatty acids is to from 2 to 80. That is found in all types of lipids and fats and oils. Now this I will show you the structure of a glycerol. Glycerol is a three carbon alcohol with three hydroxy groups. सर कितने कुछ बोले? हेलो सर.
जी बोल रहे हैं, क्या हुआ?
आवाज आ रही है सर?
हाँ जी, जरा टूट टूट के आ रही है आपका, शायद कोई कनेक्शन का मसला। अगर आपका मसला है तो आप वीडियो के बगैर फिर बोल दो, अगर आपका इंटरनेट का इशू है।
यस सर, वो तो मसला है, इसलिए मैं
कोई बात नहीं, आप वैसे बोल दो और मटेरियल आप मुझे भेज देना, मैं देख लूंगा फिर उसको। अभी आप जुबानी आहिस्ता आहिस्ता बोल दो, बेशक कोई नहीं।
ठीक है सर. I was talking about the chemistry of fats and oils. Fats and oils are composed of glycerol. Glycerol is an alcohol, trihydroxy alcohol. The ionic name of the glycerol is 1,2,3 trihydroxy alcohol, and fatty acids with even number of carbon atoms. Fatty acids, these are the acids. Fatty acids are carboxylic acids. With even number, the range of fatty acids is from 2 to 80 in lipids, that is fats and oils. For example, a small example of lipids, fats and oil, that is fats and oil, is tristyrene, a simple triglyceride. Because of some issue of signal, I cannot show the formula of this fat and oil. So I move forward. A triglyceride is called a fat if it is solid at room temperature, because a triglyceride, a saturated triglyceride have no double bonds, so that they have a high closing packing density, packing arrangement. These can be closely packed, so their melting points are high, and they are solid at room temperature. A triglyceride is called an oil if it is liquid at room temperature. This is also again coming towards the previous point, because the oils have unsaturated fatty acids, because they have double bonds in the tails. So the arrangement, they cannot be arranged closely together, so they have low melting and boiling points, and so they are not solid at room temperature, but they are liquid at room temperature. The difference is because of the degree of unsaturation and number of carbon atoms in the constituent fatty acids. Next, the sources of oils and fats are as follows. Triglycerides obtained from animal sources are usually fats, while those of plants origin are generally oils. Uh, Talking about the oils, these are from plant origin, and these are castor oil, cocoa castor oil, cocoa oil, and sunflower oil, groundnut oil, linseed oil, olive oil, palm oil, and etc. And the fats and the animal fats are butter fat, lard, tallow, and fish oils. Uh, I will explain briefly. I will explain briefly about these types of oils and fats. Uh, First of all, I will briefly explain about castor oil. Castor oil is derived from the plant. The plant name is Ricinus communis. Uh, Castor oil is differ from all other commercial oils in being rich in ricinoleic acid, approximately 90%. Compared with common vegetable oils, castor oil is more viscous, less soluble in hexane, and more soluble in alcohol. The next one is coca butter. The coca bean, the plant name is Theobroma coca, is the source of two important ingredients of chocolate: choco powder and a solid fat coca butter. The usefulness of cocoa butter for this purpose is related to its fatty acid and triglycerol composition. The major triglycerols are symmetrically disturbed distributed oilic glycerol esters of the type and include. हेलो सर आवाज आ रही है कि नहीं?
आ रही है, सबको आ रही है, आप बोलते जाओ।
सर मुझे लगा ऐसे सिग्नल प्रॉब्लम हो रही है थोड़ी सी।
नहीं आ रही है, आवाज आ रही।
ओके ठीक है,
वो
मैं
कार्टून वाला
कंटिन्यू
काम
करता
ना करो, जिसमें वो था कि वो ऐसे स्टिल हो गया कि जनाब शायद नेट का मसला, हमें आवाज आ रही है, टेंशन है।
नहीं सर, मैं ऐसा नहीं करूंगा। मैं
बोले कोई बात नहीं, रिलैक्स होके बोले।
Okay, next one is coconut oil. Coconut oil is one of the two important lauric oils grown mainly in Indonesia and the Philippines. The oil is characterized by its high level of lauric acid, accompanied by the short and medium chain acids. Next one is the corn oil. Corn oil is obtained mainly from the corn or maize by wet milling. The major acids are palmitic acid, oleic, and linolenic acid. Olive oil. Olive oil is a major vegetable oil obtained from the mesocarp of the fruits of the olive tree. The major triglycerides are OOO 40 to 59%, LOO 12 to 20%, POO 12 to 20%, and POL 6 to 7%. And the oil is characterized by a range of unsponifiable constituents which configure high oxidative stability. The oil is characterized by a high level of oleic acid with codex range of 80 to 28 to 20% for palmitic acid. Now coming towards the animal fats, that is butter fat. Butter or cheese is an important source of dietary lipids. Milk fat has a complex fatty acid composition with high levels of short and medium chain acids and with many uncommon fatty acids, including those with trans unsaturation present at low levels. Milk fat is mainly triglycerol along with some free fatty acid, monoacyl glycerols, and diacyl glycerols. Also present are cholesterol, phospholipids, traces of carotenoids, squalene, and vitamin A and D. Next one is lard. Lard is the body of fat of pig and is typically rich in palmitic and oleic acid with lower levels of linoleic acid and palmitic acid. The next one is tallow. Tallow is mainly fat from cattle. It may contain some fat from sheep, but should be free of pig fat, that is lard. Production of about tallow is treated in six or more graded dependent of levels of free acid bleached oil. The difference between tallow and lard difference in the fatty acid composition of tallow and lard reflect the fact that tallow is a ruminant fat and dietary lipid are subjected to biohydrogenation in the rumen, whereas the pig is monogastric and its depot fats more closely resemble the dietary intake. Now coming toward the refining of oils and fats. Refining, there are several refining processes, and the purpose of refining is to convert the crude oil or fat into product which are more stable for its end purpose, that is the end product is important for us. The refining involves the removal of undesirable components. The removal of undesirable components. Undesirable components that include in the fats and oils are phospholipids, free acids, mono and diacyl glycerols, color, traces metals, oxidation, and contaminants. Environmental contaminants. Impurities. Impurities removed in refining are valuable because these are the byproducts that can be recovered and used for useful purposes. Refining process. Refining process consists of 4 stages. The first one is degumming. Degumming. As soon as possible extraction of the crude oil after the extraction of the crude oil from the sources. Uh, be, next. Degumming should be carried out as soon as possible after extraction and is usually linked with extraction rather than with the larger refining process. Means to say that it should be carried out after the extraction and not the later on the refining processes. After crude oils contain up to 1200 ppm of phosphorus, equivalent to 3% phospholipid. After degumming, this level should be reduced to 20 to 50 ppm. For physical refining, the phosphorus level has to even lower than this and can be achieved with oils such as palm oils, where the crude oil has only 15 to 30 ppm, or by advanced methods of degumming. The next one is neutralization. This is this is effect by treatment with alkali and should be carried out with minimum loss of neutral oils. The resulting soap stock is separated and can be acidified to give fatty acids. This has been acidified with sulfuric. Soap stock contains free acid as sodium salt contaminated with triglycerols and phospholipids. These metals, sodium salts. These sodium salts are removed with sulfuric acid to provide crude fatty acid for soap making or as additives to animal feeds. This process also produces large volumes of acidic water, which in these environment has become an embarrassment and has increased the popularity of physical refining. Next one is bleaching. Bleaching is carried out mainly to reduce color, that is carotenes or chlorophylls produce uh, carotenes and chlorophyll in the fats and oils, and involves heating the oil at 80 to 180 degrees Celsius, mainly 90 to 120 degrees Celsius, in the absence of oxygen with a bleaching earth such as bentonite. Bentonite floods earth activated carbon or amorphous silica. These two reagents are used to bleach the fats and oils. The bleaching earth is usually activated by heating and by treatment with sulfuric or hydrochloric acid. The acid treatment earth will decompose hydroperoxides and dehydrate free sterols to sterodines. Bleaching is particularly important in physical refining since it provides the last opportunity in the process to remove. In addition to color, the remaining traces of phospholipids. Bleaching, it is used for two purposes. First one is the bleaching, but means to say that decoloring, and second one is the removing of the remaining phospholipids, soap metals, and oxidation products. And the final step is deodorization. The final step in the refining process are designed to produce an oil with bland flavor and odor and good shelf life. The removal of oxidation products responsible for off flavor and is achieved by heating at temperature between 170 and 250 degree under reduced pressure and using steam as asperage for about 1 hour. With higher temperature, especially greater than 220 degrees Celsius, there is some danger of stereomutation with linoleic or oleic acid, and is therefore particularly of concern with soybean and rapeseed oils, which contain up to 10% of this acid. Physical refining requires harsher conditions than chemical refining because of the need of volatile free acids. This can be achieved by using higher temperature, but as these promote isomerization, it is better to reduce the pressure from 3 millibar to 2 millibar and to use more steam. Next one, properties of oils and fats. First of all, density. It Density may not be seen as exciting like other physical properties, uh, but it is very important in the trading of oils since shipments are sold on weight basis but measured on a volume basis. These two values are related by density, so it is important to have correct and agreed values for this unit. The density of the density of all the oil is not same. It depends on fatty acid composition and minor components as well as the temperature. Viscosity. Number two, the next one is viscosity. Viscosity can be reported as kinematic viscosity or dynamic viscosity, with the two values being related through density. The viscosity of a vegetable oil depends on its chemical composition and the temperature of measurement. Next one is the refractive index. The refractive index is easily measured on small amounts of material. Refractive index increases the chain length, increases with the chain length, and through not in linear. It does not increase linearly with the chain length of the fatty acid and with increasing unsaturation. Next one is solubility of gases in oils. When an oil is in contact with air, the dissolved gases will depend on their individual solubility as well as their contraction in air. The high solubility of monoatomic argon enhances its concentration so that 1% in air becomes 3% of the gases in the oil. Next one is the high resolution nuclear magnetic resonance spectroscopy. A typical proton spectrum contains signals that can be distinguished by chemical shift, coupling constant, splitting patterns, and areas. The data given in the spectrum is used for the representation of the mole percent. A saturated long chain methyl ester has 5 signals with the following chemical shift: number of hydrogen atoms and splitting pattern. Uh, these are some values which will be written on the pages, and I will only read them. CH3.90, this is triplet. CH2 means that methylene, n number of methylene 1.31, brought many overlapping signals. These are a data of the graph. I will tell how this graph show the properties of the lipids and oils and fats. The spectrum indicates the presence of a straight chain saturated methyl ester, but does not distinguish between homologous in a mixture. This is from my side, and sir.
चलो जी, मुबारक हो, फाइनली आपने प्रेजेंटेशन दे दी है.
यस सर, आवाज नहीं आ रही सर.
आप अपना माइक बंद कर दो, कोई बात नहीं. अच्छा जी, ये मैं सेशन ऑफ करके दोबारा ऑन करता हूँ, फिर 1:30 बजे हम दोबारा से स्टार्ट करते हैं. फिर आपका टेस्ट भी बताता हूँ आपको और आगे पढ़ाता भी, ठीक है.
टेस्ट
130
एलएमएस पे होगा।
मैं बता देता हूँ अभी, सरप्राइज भी कुछ रहने दें, कोई बात नहीं।
सर ना करें सरप्राइज। ठीक है सर, बाय।
आप पढ़ लें, आप पढ़ लें, आपको इसीलिए टाइम दे रहा हूँ ना टेस्ट रिवाइज करने के लिए। सब
सर
कुछ
फिर
पढ़ लें।
142 पे आ जाए।
नहीं नहीं, कितने पे?
140 तक।
चलें ठीक है, 140 तक कर लो, ठीक है।
थैंक यू सर।